On 16 January 2026, engineers in southeastern Nigeria opened 4 gas wells, and one of the country's largest new gas processing plants finally came alive. But this moment should have happened more than 2 years earlier. The plant had been mechanically complete since December 2023. It cost about $650 million. It was designed to process 300 million standard cubic feet of gas every day and use fuel containing an estimate 4.6 trillion cubic feet of gas. According to NNPC, these resources could potentially support around 2.4 gigawatts of electricity generation. This is more than half of the electricity Nigeria's national grid often supply at any given time. Yet, after construction was completed, the plant could not operate at full capacity. It was not because Nigeria lacked gas. It was not because there was no power stations, factories, or homes that needed it. The problem was that the pipeline built to carry the gas across the country was still incomplete. The problem came down to a 2-kilometer section beneath one of Africa's great rivers. Engineers repeatedly tried to drill beneath the River Niger. The ground collapsed, attempts failed, deadlines were missed. A complete gas plant was left waiting on one side of Nigeria's energy network, separated from its largest potential customers by a river. So the engineers changed their plan. They built a temporary route for the gas. Then they returned to the river with a new method for completing one of Nigeria's most difficult pipeline crossing. This is the story of how Nigeria built one of its most important pieces of energy infrastructure, and then how to complete another major engineering project to fully unlock its potential. It is also the story of the breakthrough that could finally allow its gas to reach the rest of the country. Are you still watching? Kindly subscribe to my channel. Now back to the video. To understand why this plant matters, we first need to understand one of the strongest contradictions in global energy. Nigeria has about 215 trillion cubic feet of proven and probable natural gas reserve. The official figure stood around 215.19 trillion cubic feet in January 2026. This figure comes from the Nigeria Upstream Petroleum Regulatory Commission, the federal agency responsible for overseeing the country's upstream oil and gas industry. This gives Nigeria the largest officially recorded natural gas reserve in Africa. Yet for decades, most Nigerians have barely benefited from them. Here is why. Nigeria's gas industry was largely built around export markets. The Nigerian LNG facility on Bonny Island is one of Africa's largest LNG export operations. It coals natural gas into liquid form and ships much of it to international customers. Most of the LNG it produces is meant for export rather than Nigeria's domestic pipeline network. Meanwhile, gas produced alongside crude oil in the Niger Delta was often burned off into the air. This happened because there was not enough infrastructure to collect and process and transport it to where it was needed. Gas remained on the ground, gas was burned in the air, and between them, millions of generators continued to run on diesel. Long before 2021, the federal government identified 7 critical gas development projects designed to increase domestic gas supply. Then in 2021, Nigeria launched the Decade of Gas. This was a national program designed to place natural gas at the center of the country's economy and energy plans. Gas for cooking, gas for electricity generation, and gas for industries. ANOH was one of those 7 major projects. It would eventually become the first of them to begin operations. The Asa North Owaji South development, known as ANOH, is located in Imo State in southeastern Nigeria. It covers 2 oil mining leases. OML 53 contains the Owaji South field operated by Seplat Energy. Next to it, Asa North is located in OML 21, which is now associated with Renaissance Africa Energy Company. The field beneath Asa North and Owaji South contain an estimated 4.6 trillion cubic feet of gas rich in condensate. NNPC estimates that the wider development could support about 2.4 gigawatts of electricity generation. This is important in a country where the national grid has often supplied only 4 to 5 gigawatts of electricity at a time. In other words, this single gas development could support a large amount of electricity generation. The project reached its final investment decision in March 2019. The structure behind it was also historic. The plant will be built by the ANOH Gas Processing Company, or AGPC. HEPC is a joint venture eventually owned by Seplat and the Nigerian Gas Infrastructure Company, which is part of NNPC Limited. This brought together a private Nigerian energy company and the national oil company as the equal partners in separate gas processing business. The facility they designed was enormous. It would have 2 gas processing units, each capable of handling 150 million standard cubic feet of gas per day. It would include units for collecting liquefied petroleum gas, commonly used as cooking gas. It would have system for stabilizing condensate. It would also have its own 60 megawatt power station. Most importantly, the plant was designed to operate without routine gas flaring. It was also designed to collect and process gas from nearby fields that might otherwise have been burned. The purpose was clear. This project was not simply about producing more gas. It was about processing more gas inside Nigeria and bringing more of its value into the domestic economy. Construction took place during some of the most difficult years imaginably for a major project. COVID-19 disrupted supply chain, travels, and workforce around the world. The original completion date was delayed, but something unusual happened to the cost. When the final investment decision was made, ANOH was expected to cost about $700 million. After a cost reduction program, Seplat said the expected construction cost had fallen to no more than about $650 million. This included financing costs and taxes. On 29 December 2023, the ANOH gas plant reached mechanical completion. By the time the plant finally began operating, workers had completed 17.5 million work hours without an injury that caused anyone to miss work. For an industrial construction project of this size, that was an important safety achievement. One of Nigeria's largest new gas developments in recent years was complete. Wells had been drilled into a resource containing an estimated 4.6 trillion cubic feet of gas. But the plant stood in a field in Imo State without a large pipeline capable of carrying its full output into the national system. The second half of the project depended on a different pipeline. This pipeline was meant to carry ANOH's gas to power stations and factories across Nigeria, but it had its own difficult story. It is called OB3, the Obiafo-Obrinkom-Obem pipeline. It is a 130-kilometer gas pipeline running from the Eastern Gas Network towards the Oben Gas Hub in Edo State. It includes a 48-inch pipeline crossing beneath the River Niger. The pipeline can carry up to 2 billion standard cubic feet of gas every day. The cost has been widely estimated around $700 million. On a map, OB3 looks like a simple line. Nigeria's gas infrastructure developed as separate networks. An eastern network grew around gas-producing areas of Niger Delta. A western network supplied Lagos and the industrial area of southwestern Nigeria. OB3 was designed to connect these two systems and create a larger national gas network. From there, gas could also move towards the Ajaokuta-Kaduna-Kano pipeline, which is being built to carry gas into northern Nigeria. ANOH was designed to supply gas to this wider network. Without OB3, the plant could not fully reach the national markets it was built to serve. Construction of OB3 began in 2016. It should have been completed years earlier, but the deadline were repeatedly missed. The biggest engineering challenge was the River Niger. To connect the eastern and the western networks, the pipeline had to travel beneath one of Africa's great rivers for about 2 kilometers. River crossings are among the most difficult part of pipeline construction. The ground beneath a river can be unstable, wet, and difficult to predict. Drill tunnels can collapse. Equipment can become trapped underground. Engineers faced this exact problem beneath the River Niger. At one point, part of the drill tunnel collapsed. Engineers had to strengthen the ground before they could make another attempt. Repeated failures delayed the crossing for years. Throughout 2024 and much of 2025, Nigeria's gas problem could be seen in one simple image. A completed gas processing plant stood on one side of the country's energy network, its largest potential customer on the other side of a difficult crossing beneath the Niger River. They chose the second option. Just 11 kilometers from a possible connection point was Indorama, one of Nigeria's largest petrochemical and fertilizer complexes. Its large fertilizer operation depends heavily on natural gas. This made it exactly the kind of major customer ANOH needed. If the national pipeline network could not yet carry the plant's gas, a major industrial customer could use it directly. AGPC built an 11-kilometer pipeline directly to Indorama. On 16 January 2026, after receiving approval from the Nigerian Upstream Petroleum Regulatory Commission, 4 wells that had been ready since November were brought into operation. The plant achieved its first gas. This happened more than 2 years after the plant reached mechanical completion. It was also nearly 10 years after construction began on the wider pipeline network that was meant to carry its gas. Gas was finally flowing. Initial production reached between 40 million and 52 million standard cubic feet per day. During the earlier startup period, the plant also produced around 2,000 to 2,500 barrels of oil equivalent in condensate each day. ANOH became the first of the federal government's 7 critical gas development projects to begin operations. Plans also began for another possible supply route to Nigeria LNG. This interruptible arrangement could provide greater flexibility as ANOH moves towards its full capacity of 300 million standard cubic feet per day. It was a clever commercial solution, but everyone involved understood that it was only part of what the plant had been built to achieve. In June 2025, NNPC completed another difficult River Niger crossing. This one was part of the Ajaokuta-Kaduna-Kano pipeline, further north. NNPC said the engineering experience and lessons from that crossing were later used on the more difficult OB3 projects. One of the main techniques was horizontal directional drilling. Instead of digging an open trench through the riverbed, engineers drill a controlled curved tunnel beneath it. The drill starts on one side of the river, travels deep beneath the riverbed, and comes out on the other side. The pipeline is then pulled through the underground tunnel. For the OB3 project, engineers had to move a 48-inch pipe through a crossing about 2 kilometers long beneath the River Niger. On 30th April 2026, NNPC made the announcement. The River Niger section of the OB3 pipeline had been completed. It came 10 years after construction began. It followed repeated delay and failed attempts. The biggest missing section of the OB3 project had finally been completed. NNPC said the successful work was made possible by the engineering experience its team gained from earlier river crossings. Progress then moved quickly. NNPC said the completed crossing would unlock more than 500 million standard cubic feet of additional gas supply every day in the short term. AGPC also signed an agreement with the Nigerian Gas Infrastructure Company. This would allow up to 250 million standard cubic feet of gas from ANOH to enter Nigeria's national gas transportation system every day. A long-term maintenance agreement was also signed with Baker Hughes, an American energy technology company, to support the plant's operation. After waiting for more than 2 years, the plant now had a working route to Indorama and a new connection to the national gas network. Preparations were also continuing for another possible supply route to Nigeria LNG. So what did Nigeria gain from all of this? In simple terms, a gas processing plant costing about $650 million, a transmission pipeline estimated to cost around $700 million, new supply of gas for Nigerian industries, more liquefied petroleum gas for the domestic cooking gas market, a gas resource that NNPC believes could support around 2.4 gigawatts of electricity generation if it is fully developed and supplied to power stations, a gas from nearby fields that can now be collected and sold instead of being burned. ANOH showed that a Nigerian private energy company and the National Oil Company can jointly finance, build, and safely complete major gas infrastructure. The River Niger crossing also showed Nigeria's growing ability to complete some of the most difficult pipeline engineering projects it has ever attempted. The experience gained from each project can now be used on the next one, but ANOH also clearly showed the level of planning that major projects requires. A plant is only useful when it is connected to the network it was built to serve. The plant remained mechanically complete for more than 2 years while waiting for a large pipeline to carry its gas. That is an important lesson for every remaining project in Nigeria gas expansion. ANOH may be the first of the 7 critical gas development projects to begin operations, but Nigeria's wider gas expansion is far from complete. The AKK pipeline is still being built towards northern Nigeria. The electricity grid that this gas is meant to support still requires major investment, and much of Nigeria's natural gas remains underdeveloped. But for the first time in many years, The gas beneath this part of Imo State is no longer simply waiting on the ground. It's working. If you like content like this, kindly like and subscribe. See you in the next video.